Okay, sorry, I'm just really ill right now. I just wanted to crank this video out though. So first, let's look at this question. Usually, when we encounter these types of questions, it would usually be something like x plus c squared, say positive b, but you can see that it's flipped on its head, and in fact, here it'll actually be a minus b x plus c squared. So whenever you see this minus sign, we know one thing. We should take minus 1 as a common. That's one factor, right? That's our number one factor that we need to take into account while solving this. And our other factor would be, you can see that we took something as common. So something other than minus 1 should also be taken as common. So I won't write that down, but just important to know that since we're taking b, the same will apply over here as well. We're taking something common from x. And remember that the coefficient of x over here will be 1, so that'll come really important. First, let's do the first step as I discussed. Let's take minus 1 as a common. So when you take minus 1 as a common, you're going to have to flip all the signs, right? I hope you know why that is. Minus 2 plus 6x plus 3x squared. Because when minus 1 multiplies, you get a positive 2, which is the same thing over here. You get minus 6x, same thing over here, and minus 3x squared, same thing over here. Now you can see that the coefficient of x over here, specifically x in the, x squared bracket type, it's 1, right? So we should take the coefficient of x squared here as common, which is 3. So we should take minus 1 and 3 as a common, and we should divide everything by 3 inside the equation. So minus 2 by 3, I'll erase this really quickly. I don't think we need this anymore. Right. Actually, I like keeping the question nearby. Again, excuse my voice, I'm just really sick today. 6x. So when you divide 6 by 3, you should get 2. So 2x plus x squared. And just for, now let's multiply these two together to make like one, bracket. So that will be negative 3. And I want to rearrange this in descending powers of x. So 2x. That'll come in handy later. Alright, then you just do this via the normal completing the square way. So that would be x. I'll actually make a big square bracket here. Yeah. Big square bracket x squared. And if you don't know how to complete the square, I uploaded a short a few days ago, and you can watch that short really quickly to get your head understand how to complete the square. And we take 2 as a common, 2ab, so x, and the value of b here will be 1, because I want this entire equation to be the same as what's written over here, these two. And that gives me the privilege of also squeezing in an extra value. So I can also squeeze in the value of b squared. B squared here will be 1. And I want to get rid of 1 squared as well. Again, you can refer to my short, minus 2 by 3, right? So minus 3, we can abbreviate this entire thing as x plus c. So we know that the value of a will be, let's first refer to this formula, x plus a squared. So, excuse my handwriting, plus 2ax plus a squared. So you can see the value of a over here. Sorry. And the value of a we know that the value of x is, x. And the value of a over here will be 1. Look over here. This thing will be 1. So that would be x plus 1 squared. We leave these two out and work with a minus 1 minus 2 by 3. Use your calculators really quickly. X plus 1 squared, that should be minus 3 moves over there, minus 5 by 3. Right? Minus 1 minus 2 by 3. Kind of conscious about this answer. Yeah, whatever. I'm just gonna go. Okay, yeah. That should be minus 5 by 3. And then let's multiply. Now let's get rid of this entire square bracket. and we multiply 3 by each term inside of the square bracket. So that'll be minus 3 x plus 1 squared, and now 3 multiplies, and when 3 multiplies with 5 by 3, 3 and 3 cancel each other. And also, since we're multiplying negative 3 with negative 5 by 3, it also becomes positive 5. And you can see the question format over here, it's a minus, so our complete answer would be 5 minus 3 x plus 1 squared. That's your final answer. Now let's keep that equation in mind. I'm going to erase all of our working done over here. And I'm going to teach you how to also find the range from this as well. So basically, when we take the range, now it's super easy for us to like execute from here on. So I need you to just look at the equation, and you need to have like a sort of mental understanding of what quadratic graphs look like. Oh man, one of the most tiring features, annoying features about this, right? So I need you to just look at what quadratic graphs look like. You can see that the coefficient of x squared here is negative 3. This is really important. When the coefficient of x squared is negative, it doesn't open upwards like this, you know? I hope you know this. It doesn't open upwards like this. Instead, it actually opens downwards when it's negative. So it should be something like this. Like this. Where this is the x-axis and this is the y-axis. So keeping that information in mind, I'll just keep this drawn on over here, a very rough sketch, and I'll like to actually move that to the side with a neater drawing. So that would be, this is what our graph will look like. Alright, so this is just a very rough approximation of what our graph will look like. So in order to find the coordinates of the vertex, right, the coordinates of the stationary point, what we do, we can refer back to our equation over here that the question made us write. In this case, it'll be 5 minus 3 into x plus 1 squared. I'll teach you how to find the domain and the range. So when we need to find the domain, just equate this, x plus 1 to 0. So the x-coordinate of the vertex here is minus 1. And now to find the range, or to find the y-coordinate of the vertex, ignore this entire thing. Ignore all terms that have to do anything with x. Just focus on the constant. The constant in this equation that has nothing to do with x, that's the y-axis of your vertex. So the y-axis of your vertex is 5. So I just realized it should be on the negative x-axis, but I hope you guys can excuse that. So you can see that the highest possible value of y over here will be 5. The equation or the graph never, the y value of this graph never really exceeds 5. It reaches 5, but it never exceeds it. So how will we represent that in the terms of inequalities? You have to think very carefully. So you know that y is smaller than, you can see this entire, excluding the y, right? You can see that y values are smaller than 5. So it's 5, but at this specific point over here, it is also equal to 5. And that's your range. That's the entire question. Alright, so let's look at another equation as well. If f of x is equal to x squared plus 3. And so x squared plus 3, and they're asking us to find the range for these functions in the domain minus 2 x 5. Right. So since they're really generous and they just gave us a domain here, so we just need to plug in the minimum and the maximum values of the domain. So we already know that this will be like the graph should look somewhat like this, right? So we put in minus 2 square plus 3, and y is equal to 7, right? 4 plus 3 is 7. And then f of, I should have put minus 2 over here. And then f of 5 is also equal to 5 squared plus 3. 25 plus 3 is 28. So you can see that y, you can see that in this equation, since it's going upwards, we can assume that it happens somewhat after this, right? In this point. So y, so the first value of y was 7, the second value of y was 28. So y is greater than equal to 7. Since it's a quadratic graph, I assumed, right, using my mathematical knowledge, I'm about, like, I just assumed that we were in this portion of the graph, since the y values are constantly increasing, and the coefficient of x squared is also positive. So I assume we're over here. So y is greater than or equal to 7, smaller than or equal to 28.